Okay, so constant proportionality. What does constant mean? Stays the same, keeps going, doesn't change, right? All right, so how many cups of mix will he use for 12 pancakes? One. It's not a trick question. How many cups of mix will he use for 24? Two. All right, so what is the ratio of cups of mix to servings? 1 to 12. Why is it not 12 to 1?
Because it says cups of mix to servings.
Cups of mix first, and then to serving second. All right, so what happened to 1 to get to 12? Did it happen from 2 to 24? Okay, how did I get from 1 to 12? How did I get from 2 to 24? Times 12. That is our constant, okay? So a relationship is proportional when the ratio of y over x is constant. So this is x, this was y. All right, so we had 12 over 1, which equals 12, and then we had 24 over 2, which equals 12. It had a constant. All right, the value of the ratio of two proportional quantities. All right, if it is represented by the equation k equals y over x. Okay, k, we're going to write this right here. K is our constant. They make the same sound, right? Okay, that's what kind of is going to help you remember that k is your constant. All right, so the last class said they remembered this part of it from last year because you have an independent value and a dependent value. Do y'all remember which one is which? Y is dependent. Okay, and x is the independent value. What's the difference between dependent and independent? It depends on something. So the last class said something about time. Time can never be what? What do you think? Yeah. Time doesn't depend on anything. Nothing can change time, right? Time keeps going, period. There's no stopping that. So I have time. Would time ever be on my y-axis? No. So if you ever had a graph and you were trying to figure out which one's dependent, independent, and there was time there, time would always be your independent variable, right? Okay, so we use the equation y equals kx to represent proportional relationships. What is k representing? Our constant. This right here finds your constant, and this right here just puts it in the equation. So we start off super simple. So it says for the ratio of y to x, determine if each table represents a proportional relationship. So if it's constant the whole time, it is automatically proportional, okay? So it says y over x. Well, what's my y value in this table? 6. So I have 6. My x is what? 1. So if I do 6 divided by 1, what does that give me? 6. Okay, so my y value is 12. So what's 12 divided by 2? 6. All right, so I have 18 over 3. What's 18 divided by 3? 6. And then 24 divided by 4. So did it have a constant?
Yes.
That means it's proportional. And then it asks for my constant. Well, what was my constant? 6.
So if it's constant, then it depends. Independent?
No. If there is a constant, it's proportional. Okay. The independent and dependent is just labeling your x and y values. Okay, so this one, 10 over 2. What is 10 divided by 2? 5. And I have 15 divided by 3. 20 divided by 4. And then 25 divided by 5. Okay, was it proportional? Yes. Okay, my constant is 5. Okay, what do I notice is a little bit different on number 3 than it is? Okay, it's flipped. It's smaller. My 4 is on top, and then my 8. What is that?
2.
4 divided by 8. That's a fraction, right? It's a value less than 1. Yes? Can I reduce that fraction? What is 4 out of 8?
2 out
A
of
half.
A half. 1/2. So my constant is 1/2. That's just saying it didn't progress by a whole number. It progressed by halves. So 10 over 5, or no, 5 over 10 is still 1/2. 6 over 12 is still 1/2. And is 7/14 1/2? Yes. So what was my constant? 1/2.
Kylie, you're gonna fall asleep again.
Kylie, put your head up. All right. The cost of 6 pounds of almonds is $23.28. What is the constant of proportionality that relates y, the cost in dollars, to x, the number of pounds? So I need to put y over x to find my constant. Which one is y? How do you know that?
because it's the cost.
Yeah, it says y, the cost in dollars. This is my dollar amount. So I'd put 23.28 on top. That means x is what? 6.
So you divide 6 by 23.28.
You divide 23.28 by 6. Okay, well, 6 times what gets me closest to 23?
3. Almost said 8.
4 is too much.
I know,
3.
18, that leaves me with 5. 6 times what gets me closest to 52?
8 and it's
48. And then 8 again. So my constant was what?
3.8.
That's how much?
It's how
Like this. This is easy.
Kind of.
kind of.
The homework is easy today. Everybody did well with it. I'll explain that in a minute. Okay, a car travels 220 miles in 4 hours. What is the constant of proportionality that relates to y, the total number of miles, to x, the number of hours? Okay, so I need k equals y over x. So which one's my y?
220.
How do I know that?
It's 220 because the total numbers of miles.
Y is the total number of miles. So I have 220. And then x is hours, so 4.
It would be 55.
You do that way too. Yeah, she was using it. I haven't even wrote down the dividing thing. Oh, she doesn't. You're right.
Don't say that. She was writing it down. 84.
Yeah, it's 106. I remember that.
What?
We're making fun of Justin.
No,
Here.
that's not nice stuff. All right.
I got green.
Okay, use the graph below to complete the table and answer the following questions. All right, so can I fill this table out if I have these points? Yes, right? Okay, so what is my very first point?
0 to 0.
Okay, we'll talk about this more later, but do y'all remember what this is called on a coordinate plane? The point origin, okay? So if it ever starts at the origin or goes through the origin, that means it's proportional, okay? That means there is a constant, okay? Because this is the number of tickets. This is the total cost. If I bought 0 tickets, I should have 0 cost, right? Okay. Well, but sometimes it'll be like, well, there's like an entry fee or a one-time fee or something. Okay, but since I spent 0, I should have 0. Or I bought 0, I should spend 0. So 0, 0 means it's proportional automatically. All right, so the next one, my x value is 1 and my y value is, so 1 to 10. 2 to 20,
3 to 30.
and 3 to 30.
So the constant is 10.
Okay, so remember y goes over x. So I have 10 over 1, which equals what? If I put 20 over 2, does it still equal 10?
Yes.
Yes. So my constant is
What I
10.
did is that I just times.
Yes, that's fine too. Okay, so it says, what does the point of 110 represent in the relationship? So that means, like, what does it mean? Anytime you see the word, what does it represent? What does it mean? So if I have 1, well, what is 1 representing right here? Okay, so you would say 1 ticket cost what? It just wants an explanation that you know what that graph means. Okay, so this one, what's a little bit different compared to the previous one? There's not dots. Does it start at 0, 0? No, it starts at 0, 0. Okay, and then I have 1 to 3, so it is perfect right there. What about 2 to 6? Does it hit exactly? Yes. We've got 3 to 9. Okay, my constant is 3. Because I can multiply by 3, right? 3 over 1 is equal to 3. Okay, so what does 1, 3 represent here? 1 hour, what?
Miles walk. Or how, or 1 hour is like 3 miles.
One hour to walk 3 miles. Okay. Your homework looks, there's only 9 questions. And the bottom half is like this. Okay. So here's the thing. It's pretty easy. If you come ask me a question, I'm going to ask you to bring me your notes. And you're going to show me to find your answer, guys. Because a lot of you are thinking like we take notes just for you to take notes and put it in your binder and never look at it again. Your homework, your notes will help with your homework every single time. All right? No, you can't use your notes on a test. All right. While training for a marathon, Keith's watch reported the number of calories he had burned at each mile marker. The data is shown below. Okay, is the number of calories proportional to the number of miles? All right. 1 to 17. So this is my x, this is my y. Well, what's happening to x to get to y? How do I get from here to here? Yeah. So I'd multiply by 117. So I need to figure out, though, did that work every single time? Okay, I'm going to go to the last one. So 117 times 5.
Yes.
Okay, did it work? Yes. So is it proportional?
Yes.
Yes. Hmm. Well, because it, well, you can say because it has a constant. Because the next question's asking, what is the constant of proportionality? 117. Okay, it says write an equation to represent the relationship between the number of miles and the number of calories. On the front, we wrote an equation. And it's this. Use the equation y equals k and x. I have a k and or a y and an x here, right? All right, what is my k? What is my constant?
117.
So it's saying you could use this equation for this graph. Okay, because if I plugged in 2 to my x, well, 117 times 2 should give me what for my y? 234. Okay, so the next day Keith ran 7 miles. How many calories did he burn? All right, well, the number of miles, that's my what value? My x. So I would put y equals 117 times 7. So he burns how many calories?
819 calories.
Okay, so the next one said if Keith's watch reported that he burned 1,170 calories, how many miles did Keith run that day? So out of here, what was my calories burned? What was my calories burned, X or Y? Y. So instead of putting Y equals, I'm going to put this for my Y and 117X. That's just a one-step equation, right? Yeah. So then I would try to solve for my X and I would divide. What is the only difference between this number and this number? A 0. So that means it had to multiply by what? 10. Okay. Not so bad, right?
That's true. Like 1 mile, you burn 100.
Oh, it just depends. No. I would say probably not. That seems excessive. I'm going to say, like, no.
Yeah, I
Okay.
didn't think it was that much.
No.